Hello again and welcome back. This is Joe Strout and I'm doing a series developing a little game called Base Defender. So let's get right into it. Yesterday I created just a main program and it lets you move around this green star, which is the player, and deal with these orange enemies, which will chase you if you're close enough. Otherwise, they'll go and attack the castle. So our goal for today is to add collision detection and damage so that if I run into any of these enemies, they flash and take damage and eventually disappear. And when they run into me, I flash to show damage. I don't think I'm going to have the player in the castle actually do anything with the damage today because that would tie into a larger game. And then we'll also have the enemies detect collisions amongst themselves and not take damage, but try to avoid driving on top of each other like that. So I think that's a pretty good goal for today. So let's see, where to begin? I only want the player and the enemies to damage things that they're facing. So we needed a way to tell if a sprite is facing another. Or in general, I guess it could be a method that tells if a sprite is facing anything with an X and Y, like a mouse, which will be a good way to test this. Because mouse has X and Y properties just like a player, such as sprite, which has X and Y properties. So let's start with that. We want a utility, well, not really a utility function, a sprite extension, I think. Sprite that is facing equals function target, and this can work for any target with an X and Y. So maybe I'll just call it, no, we'll call it target. That's a good name. And so how do we tell? Generally, we're going to use some trigonometry again. Or should we use the arctangent? Arctangent would give us, no, I think we can use, wow, I'm making this up as I go along. We could use the dot product between the sprite's forward vector and a vector pointing at the target. Dot product is, actually, I think that's something that we have in list util. Let's take a quick look at that. I haven't made changes. Oh, I guess I did. I started on that method. And here's an easier way to get to a library. We'll just use edit find file. Syslib list util. Let's see what we've got here. Yeah, list dot dot. So we don't even have to implement dot ourselves, but it is just the sum of the products. So it would be x times x plus y times y. If x and y are well, I'm not explaining this very well. It'd be forward x times delta x plus forward y times delta y, where forward is a vector that points in the direction of our sprite, and delta is a vector that points in the direction of the target. You know what? This is all working too hard. I am going to just use atan. So after all that rambling about dot products, we're not going to use it. We're just going to use angle to target equals atan of target dot x minus self dot x. Oops, I'm sorry. Atan takes y first for historical reasons, or mathematical reasons, I guess I should say. And then we're going to go ahead and convert this right away to degrees, because atan gives us radians, so there's 180 degrees per pi radians. There we go. And then we can do angle diff equals, let's see, absolute value, because we don't care which way, whether you're left or right of the target. So absolute value of angle to target minus self dot face direction. And for debugging purposes, I'm gonna text.row is 25, print diff, plus some spaces, and if angle diff is more than 180, then we'll do this before printing, because we know this might happen, right? The angle of the target might be, I might be facing direction 0, and the angle of the target might be direction 350, and that would give us 350, but we don't need to know that much. Actually, subtracting 180 wouldn't even suffice. Yeah, we want to subtract 360. So it's the same angle, but it's negative in that case, and that'll give us the angle we need. And then let's return, let's see, we should make it a parameter, how close of an angle counts as facing. Angle limit, but by default we'll make it 90. If you're facing sideways from your target, are you really facing it? Not really. Okay, how about 60? You gotta be within 60 degrees. All right, so we'll return angle diff is less than angle limit. Okay, so let's run that. It's just doing what it did before, but now we're going to bang out a little test program. While true, print player that is facing the mouse, yield, and while. Oh, direction not found in map line 44. Self dot rotation. Yeah, it's not called direction, it's rotation. Okay, so this is our player. He's facing directly to the right. So now we're going to compare that to the mouse. So I should have done this kind of all in one line so it'd be easier to recall. Print player that is facing the mouse, yield, and while. Okay. This little 1 here and 0 is the response of the program. So if my mouse is here, that counts as facing it. Back here does not. On the other side, here is facing it. Here is not. So that looks like that's working fine. Let's rotate the player a little bit and make sure that it works in other orientations. So just rotate the player like this. Repeat our test. So this is facing the mouse. This is not facing the mouse. Oh, hold on. Oh, it's a good thing we tested. Look at this. When the mouse is over here, it's failing. Because our angle diff is negative. How can our angle diff be negative? I thought we were taking the absolute value. Let's have a look at that. Angle diff. Oh. Yeah. We were taking the absolute value, but then we were subtracting 360, so we need to do angle diff minus 360 and then take the absolute value again. That's what I think is going on. So let's point down-ish and then run our little test. Okay, so now 0 here means not facing the mouse. Get over here, we're facing the mouse. There we go, sweet. Boy, I sure hope that the mouse shows up on the screen recording. I'll check that out later. Okay, so we can now tell if a sprite is facing another sprite. Next, let's add something that causes a sprite to flash to show that it's taking damage. Because without that, it's going to be hard to tell if the rest is working. So, what do we need for that? Well, we need a flash color, or flash tint, we'll call it. No, actually flash color. By default, we'll have them flash white. That's not a good choice for default. Have them flash red. And then, let's see, the flash is going to come on fully that color, and then it's going to quickly fade away. So we need to keep track of what the current flash intensity is. And this is in a range from 0 to 1. And then we'll have a method to update the flash. And all that's going to do is self.tint. Let's see. We need something to start the flash. And that's going to tuck away the current tint if we don't already have it. How do I tell? Let's see. Sprite dot normal tint is null. Okay. If self dot normal tint equals null, then self dot normal tint equals self dot tint. And the reason I'm doing this is we're going to have to go back to the unflashy color, the normal tint. And I don't want to have to make all the users of this code manually store the normal tint. So I'm going to grab it the first time you call flash, if we don't already have it, and store it on this object. That should work fine. So now we can do self.flash intensity equals 1. And we'll immediately do self.tint equals flash color. Okay. So then when we update the flash, we can do self.tint equals color.lerp from the normal tint to the flash color. Yes, that should have been self.flash color up here. Lerping by how much? Self.flash intensity. And then self.flash intensity. I should do this only if self intensity is greater than 0. So if it's less than or equal to 0, then you just bail out. All right. And we'll just reduce the intensity by 0.1. That should do it. So you call flash, then you call update flash. And you could call this on every frame, but yeah, that should do that. All right, let's try flashing the player. That sounds kind of funny, but anyway, player.flash makes it red. What I really want to do is while player.flash intensity greater than 0, player.update flash yield and while. That looks pretty good. But let's try changing the player's flash color. Color equals color.white. It's pretty quick flash. I hope that's showing up on the recording, but it doesn't look too bad. We might slow down the decay a little bit. So instead of doing 0.1, we'll try 0.05. And I'm going to try flashing in white again. Yeah, that looks nice. Okay. And this will work for anything. I could do enemies. Well, I'm not going to demonstrate because I need to do the whole loop. But we could do it on any enemy. We could even do it on the castle. So, things can flash now. That's great. I guess the next step is we need to add a bounding box to all sprites so that we can start detecting collisions between them. Okay. And maybe I want this to be a helper method on sprite again, because otherwise I'm going to end up repeating myself a lot. It's never a good idea to repeat yourself in code. So sprite.add bbox equals function inset equals 0. That's how much we're going to reduce the size of the bounding box from the size of the image. We'll do self dot, boy, it's been a little while since I've done this. This would be a good time actually to bring up the mini micro quick reference. It's what I'm always telling other people to do, so I should do it myself, right? So I'm going to go to my files where I have tucked away here somewhere. Let's see, files and MiniScript manual, no. Mini micro cheat sheet, that's the one. All right, here it is. Cool. And we're going to go to the bit about sprites. Here we go, sprite class. Local bounds, that's what I was struggling to remember. It's the bounds relative to the sprite. And the bounds class has x, y, width, and height, and some other stuff. All right, so going back to mini micro. Self.localBounds, those new bounds, local bounds.width equals self.image.width minus inset times 2, because you're going to inset it on the left and the right. And that should do it. All right, so we can add bbox for any given inset. So for the player class, because it's shaped like a star, this is the player, and it's in a 48 pixel box like this. So we want to inset it quite a bit. It shouldn't take damage until it gets in here. So we're going to set it like 16 pixels. So back to the macro. Player, we can do player.add bbox inset of 16. All right, and we're going to test that again with a little manual loop. We're going to say while true, if player dot, let's check our micro again, contains point. And that's a bounds containment test using the bounding box, so that's a fine way to check it. So if player.contains mouse, then player.tint equals color.yellow, else player.tint equals color.gray, yield, and end while. Okay, so now we should be able to see when I'm mousing over it. Hey, I really hope the mouse shows up in the recording. But if not, trust me, when I mouse over the star here, over sort of the interior area, not the outermost points, then it lights up. So I can tell that that's working. Very cool. All right. So we've done that for the player. We should do it for the castle as well. Let's take a quick look at our castle sprite in the original drawing program. And I have figured out now how to switch these layers without having to scroll down. So yay me. All right, here's the castle. And these are 64 byte large grid squares here. So this is, let's see, and these are 8, so 8, 16, 24, 32. So if we were to inset by 32, that would be just this square area, but maybe I won't be quite that aggressive. We'll inset by 16, and that'll let the castle take damage anywhere that includes half of the tower area and close enough to the interior area. The secret to good performance in games is to not be too picky about how close of a collision you require. So where's our castle? Enemies, players. I know there's a castle in here somewhere. Oh, there it is. Castle class. We'll do it after the tint. Castle dot add bbox 24. Maybe, actually I said 16, didn't I? Yeah. Okay. And is flashing red what we want? Well, we can tweak the colors later. That's easy. Might help if I spell it correctly. Okay. Now the enemies, I feel like this program is starting to get a little bit long already, and enemies are going to need a fair amount of specialized code, so I'm going to start moving things into separate modules, and I'm going to start with the enemy class. So all of this stuff we can cut, save and close, and edit enemies. Oh yeah, I can't do it that way. Reset, edit, paste, and then save it as enemies. And I guess the first thing we should do is make this still work exactly as it did before. So create some enemies. That's fine. Let's edit the main program and import that. It's not really going to work to import it up here, is it? Because it's using things, it's going to want to use things like add bbox. Well, first thing I'm going to import is import util. Yeah, import util gives us an ensure import function, which is handy in making sure that modules don't get imported more than once. But then we're going to have to make some more modules because if we look at enemies, oh yeah, what is this using? Well, it's not using anything at the moment, but it is going to be using the add bbox function. So maybe actually, since it's not, no, the other thing it does is it's adding things to the sprite disp. It's using sprite disp. So this really needs to come after general setup code. Or we need to call a setup method. That's better. Okay. Setup is function, do all this stuff, and function. Yes, of course. So in general, it's a good idea for a module only to define classes and functions, but not actually do anything until it's told to. Let the main program be in control of when this thing sets itself up. So save that, close it, edit main, and we'll import it at the top. So we can use ensure import. It's the main program. It doesn't really matter, but it's generally a good idea. I don't know if it's a good idea, but it makes me feel better. Okay. And then down here, we'll do enemies.setup. Hey, look, it still works. Hooray. Now we want to start getting these things to detect collisions. So we're going to do enemy.add bbox, and these things are very square, so we're not going to need to inset much. Take a quick look at our enemies again. These are the enemies. They're in a 64 by 64 box, and they almost fill it, but we could inset maybe 8 pixels. And yeah, that would be a good amount of overlap. So going back to mini micro, add a bbox and set by 8. And now, let's see. Let's make this start doing things. Do I want a separate method for this? I think I do. Self.check collisions. All right. Enemy.check collisions. is a function that does what? Well, for sp in sprite disp.sprites, if self.overlaps sp, and if we're facing it. I only want to deal with collisions on things that we're facing, because these guys always move forward. But I wonder which is faster, checking overlaps or checking facing. That's a good question. For now, we'll assume overlaps is faster, so we'll check that first. Okay. Self.hit sp. We'll just do that. We'll assume we have a hit method. And let's do that. Enemy.hit equals function other. So we're hitting another sprite. What do we do? Well, for one thing, I think I want to reduce our speed to 0. And that'll be true no matter what we're hitting. Self.speed equals 0, and then we'll build it back up. So we should do that right here before we move forward. Self.speed equals math utils.move forward from self.speed to enemy.speed at, I forget how fast we want to increase, but 0.5 maybe is good per frame. So this way, if we set the speed of an individual enemy to 0, it's going to accelerate back up to enemy speed, which is 4, at a rate of 0.5. Okay. So we can set the speed to 0 when we hit something, and then what we do depends on what the other thing is. But yeah, because I don't want enemies to actually damage other enemies. So if other is a enemy, then return. Don't do anything else. And that would be a very common case. These guys are always going to be bumbling into each other, so it's good to bail out quickly. But if it's not an enemy, then that means it's the player or the castle. We want those to flash, so other.flash. I think that'll work. Let's try it. Run main. And I'm going to do a reset run main. Oh. Undefined identifier unit sprite image. Oh, yeah. No. I actually don't understand why that is. Oh, yes, I do. Because we're importing enemies here, and we're not getting our images until here. So this is a good example of where more modules would actually make this easier. Like this stuff, for example, the sprite sheets and the image and the building sprite sheet, all of this could go into like a resources module, whose job it is to wrap up references to resources for the project. So reset, edit, yeah. Okay. So we're going to save this as resources, and then edit main. We're going to ensure import resources, and then we'll do the same thing elsewhere. But we have to make sure that we're actually using that now, where we set the sprites. So this is going to be resources dot player sprite image resources. You know what, this really should just be castle image. All right, let's sort these a little better. Here's all the unit stuff. Here's the building stuff. Okay, and then edit enemies, and we'll. I usually like to make my modules runnable and testable on their own. You don't have to, but in case we do that, we'll import util, and then ensure import resources. And then we can just do resources dot unit sprite image, and that should work. Reset run main. Enemy color. Oh yeah, that's also a thing. Well, do we put these constants in their own module? Yes, that's the right thing to do. Fine, let's do it. I'm gonna cut these out of here. Imagine I have a constants module. I'm gonna go make it. Alright, and we have to use that here. Sure, import constants. Okay. And then in main, we have to make sure we're referencing it via constants as well. I mean, I could just have those constants stuff themselves into the global namespace, but it's a little neater to have things divided up this way. So constants player color, constants player color, and we're starting to get organized. All right. Castle is unknown enemies.ms. Oh, yeah, that's interesting. Line 12, meetup target equals castle. That's something we shouldn't set until setup. Okay, that'll work because by the time setup is called, castle is defined as a global variable. Reset, run main. Okay, move toward not found. Really? Move towards angle. But that's not what you said. It was move toward. Enemies MS line 26. Oh, part of Matthew Till. I think it's moved towards. Okay. Reset run main. Okay. Now they're getting quite slow when they run into each other, and then faster. These guys don't look to me like they're running into anything, and yet they're moving quite slowly. Why is that? Something funny going on there. You remember that mouse test we did on the player sprite? I'm going to do that on one of the enemies. We'll call it E. Enemy 0, E dot. Right, enemies is a module now. It has an enemies list. What you talking about? Enemies not found in map. Enemies dot indexes. Import util enemy and setup. Oh, our enemies list has become a local variable. Store this in outer so that we can get to it. But the other thing is, let's see. Yeah, add bbox 8. Okay, checking collisions. Looking at all other sprites. Oh, you know what? Everything is colliding with itself. Yeah, that's not cool. If SP is not equal to self and these other things are true, then hit it. Okay. So that'd be the problem right there. Reset run main. Okay, now they zoom along. and they don't slow down until they hit something. Cool. Now, our flash is not deflashing. Everything's staying red because we forgot to call update flash. Also, we don't really need to be printing the angle diff anymore, so let's hit it. Sprite, flash, update flash, that's fine. Angle diff, here we go. Take that out. And we just need to call update flash on all of our sprites. So we'll just do that here. Yeah. Cool. Look at him. Now let's see if I can hit any of these guys. Boom. Boom. They're actually quite hard to hit because of the way this thing... Ah. This thing corners like a truck. Oh yeah. I remember now. Shoot. Well... Oh, you know what else it is? Because these guys start orange, it's actually quite hard to see when they're flashing. So we're going to change the flash color on those. But even so, I may have a flaw in my game design because, or at least in the mechanics of how the player moves, because it is quite hard to turn around and hit one of those things once they're on your tail. Anyway, enemy.flash color. I guess I could put it in the constants module, but I'm just gonna have them flash white for now. Man. I cannot hit these guys. They get on my tail, and I am powerless to... Oh, wait a minute. There's no code to hit them. We'd have to put that on the player, right? Okay. So I'm going to do that, but... Yeah. We might end up changing the rules for how the player hits. Maybe the player damages all the enemies around it so that it doesn't have to actually face them. Of course, that means you could just sit in the middle and the enemies would come and you'd be damaging them. So I don't know. But I'm going to start by copying the way enemies work. I can copy all this code, actually. We'll just do this in main for now, but probably the player should go in its own module. Yeah, that's true. Okay. Yeah. So I'm going to save this, but let me go ahead and move this into its own module. On the clipboard. Right, I keep thinking that works. It does not work. Reset. You gotta create a program and then save it. I'm hesitating because I'm thinking, how do we want to refer to this player? Right now, you'd have to refer to it as player.player. Because it's in the player module, and then it's called player. Which isn't terrible. It's kind of like enemies.enemies, which we've also got. So maybe for next time I'll think about whether I want to... So I feel like it should be a global. The trouble is... then I can't put anything else in this module, because if I Yeah, it's kind of a pain to replace a module of the same name with an object like a sprite. I could do it, but my instincts are telling me that's unclean. So it's going to be player.player for now. But in any case, let's see what we're doing here. We're handling the collisions after we move forward. And we check all other sprites. And if it overlaps and it's facing, then we hit it. And what do we do when we hit something? We set our speed to 0. And we only want to hit enemies. So if it is an enemy, then, hey, look, it's another bug. I'm pressing the forward delete key, and in addition to forward deleting, it's inserting a junk character. So that's why this version is not yet released. That's 2 bugs. Sometimes when I hit F5, it inserts a junk character, and also when I push delete, it's inserting a junk character. I think I know what that is. I'm going to fix that later today. But what we really want to do is take damage. Oh boy. How much damage? We should probably tell it. We'll just say 1 for now. And this is something that enemies need to know how to do. They should know how to take damage. So, if it's something like the castle, player doesn't damage the castle. Let's edit enemies. And we'll have enemy.take damage equals function amount. And we'll just do self.flash for now. Later we'll add some hit points and all that. Okay. Now, is there any place where we're referring to the player? No, we're not referring to the player at all anymore. So let's do it. Ensure import player. And you know what? The player is going to have the same problem that enemies had, that it needs to be set up at the end. So player.setup. Let's edit player, make sure that it works that way. Actually, much of this is going to work fine already. Import detail. Ensure import resources and constants. Resources constants. But pushing the player onto the sprite disk, that needs to wait for the setup phase. The rest of this I think is okay. Yeah. Yep. I think I'm okay with that. Let's try it. Reset, run main. X not found, math util line 70. Real problem is no doubt somewhere else. Enemies line 18. Okay. Enemies line 18. What are you doing? Here's where we're doing it. Player.player. Player.player. Where else are we referencing the player? Just there. Okay. Right. So that's what I was talking about before. It has to be player.player because player is now a module that contains all this other stuff, including the actual player sprite. So player.player to get to the sprite. Reset run main. All right. Aha. Enemy is unknown in this context. Right. Player.ms line 46. All right. Now here's a little different. Enemy is a class. And I'm kind of okay with modules stuffing classes into the global space. So I'm going to fix this. And I could say enemies.enemy, right, to refer to that class. But instead, I think I'm going to just stuff this class into the global namespace. So we'll fix it in enemies. And by just saying globals enemy equals new sprite. Okay. Reset run main. Hey, oh, okay. But you can see I did damage these guys. Boom. You can see I'm turning white as I bump into them. It is hard to turn around and hit one that's on your tail, though, which was not an intentional part of the mechanic. I should probably do something about that. But first, let's get it so you can actually destroy these enemies. Edit enemies. I keep wanting to type ENI for some reason. I don't know why. All right, so take damage. What we need here is hit points. Start them out at 10. We're going to flash. We're going to do self.hit points minus equals 10, or minus equals amount. And then if self.hit points is less than or equals 0, then self.die. Enemy.die equals a function. And I really don't think we need to do much in this case except enemies.remove value, which is not a built-in method, but it's something we can get from listutil. So normally, if I just said enemies.remove self, it's not going to work because remove takes an index, not a value. So if you want to remove by value, that's what the remove val function does, and that's added by listutil. So remove val self, and we can also do sprites, this sprites remove val self, and now Bob's your uncle. All right, so let's test that much. We should now be able to actually destroy enemies by hitting them 10 times. And I'm just gonna kind of like make passes through these guys. Yeah, we gotta fix that. This big arcing turning makes it way too hard. Especially since it seems like, I mean, the enemies aren't actually any more nimble. They're a little bit slower even. Maybe the fact that they're slower allows them to turn tighter, which is ironic that that's better, isn't it? Come on. Surely I've hit these guys 10 times. Some of them. You know what? Here's a secret. Wait until they just... No, that doesn't work. Okay, let's see what's going on. Enemies. Let's pre-print that. Oh, this is still a lot. Okay. Is an enemy. It's got the target. That's the problem. It's showing the target, which is going to be the castle or the player, and all the information for that on everyone, but that's fine. Where's the hit points? Oh, right. This is interesting. Equals enemies 0. Right, enemies 0. You got hit points. What do you mean hit points not found? I didn't save my changes? Huh. I guess the great thing about recording while you code is if I really wanted to, I could go back and figure out what the heck I did there, but my changes are gone, so we're just going to redo them. Hit points equals 10. And take damage, we're going to do self.hit points minus equals amount. And then if self.hit points is less than or equal to 0, then you die. Enemy.die equals function. Let's see. Enemies.remove value self. Right. This dot sprites. Remove val self. And at the top, ensure import listutil. Save it. Program saved. All right. Okay, there we go. So some of them were trying to die, and then it said die unknown. Why did it say that? Because I didn't say self.die. Cool. Oops. I didn't want to just run that. I wanted to reset run main. Hey, look at that. Now I'm able to kill these guys. Except for the last one, which gets on my tail and I can't shake him off. Wow, that's super annoying. There we go. And I got him. Okay, cool. Now, how are we going to fix the mechanics on this so that they're not so hard? I like the idea of just pushing in the direction you want to go. Feels kind of, it's meant to feel kind of like playing Gauntlet. But it's not doing that. It's turning like a truck instead of like a tank. So a simple fix would be to just have it turn instantly. And all that work I put in last time into figuring out how to gradually turn towards an angle, yeah, we're not going to use that. Oh, this is in player. Player module now. So instead of move towards angle, we would just say self.rotation equals dir. I'm going to keep this code commented out in case I want it. Because I could just also turn much faster. But let's try just turning instantly. Let's see how that feels. Wow, now I'm super powered. Boom, take that. Well, that definitely feels more like playing Gauntlet. Let's try turning, but much faster. I mean, if we made this last number is the maximum number of degrees will turn per frame. If I made it 360, that would be equivalent to turning instantly. What if I make it 90? That's kind of nice. You can still see it turning. But if I want to just turn around and get this guy, I can get him. Boom. Come here, you. Boom. Take that. Haha. All right, cool. Yeah. I think the only thing I might want to add, since I have a little bit of time left before we're approaching an hour, let's make it so that enemies continue to spawn. So instead of just a wave of enemies at the beginning, enemies will continue to spawn, for now, just indefinitely. In the real game, of course, we'll have to have a limit to how long the wave is, but we'll still want enemies not all appearing at once. So that means the enemies module needs an update method. And let's see. Let's move this enemy creation into a spawn method. Spawn equals function quantity, which by default will be 5. And that's how many we'll do. Range 1 to quantity. Spawn a new enemy along the bottom of the screen, and we'll do this initially, spawn. But then what we'll also do is we'll set a next spawn time. So outer.next spawn time equals time plus, how often do we want to do this? 10 to 30 seconds. Okay. And then we can do if time is greater than next spawn time, then spawn. Cool. Now we just need to remember to call enemies.update from the main program. Update all the sprites, enemies.update, and that should do it. Let's reset run main again. I better kill these guys because there's more coming if I've done my job properly. Okay, maybe 10 to 30 seconds is too long. I got nothing to do here. Now, it would be fun if the enemies drop, like, coins, and then you could go around and... Oh, there's they are. There's more. Haha. It'd be nice if they didn't always spawn 5, too. They could spawn different numbers, so... yeah, if the enemies drop coins, then you could go around and collect them, but maybe that's a little pointless, because, at least right now, the only way enemies die is from the player, and you're right there anyway. But later on, we're going to have towers and hazards and things that might take out enemies when you're not around. So you could go around and collect their coins. That could be fun. But for now, I just want to change the way they spawn. So we're going to reduce the spawn time because 10 to 30 seconds seemed way too long. Let's try 5 to 15 seconds. And instead of a quantity of 5 all the time, we'll say if you don't specify a quantity, then quantity equals ceiling of 3 plus 7 times random. So that'll give you, actually it'll give you probably 4 to 11. Could be as little as 3. R&D can return 0, but it's extremely rare. Okay, so let's try that. Okay, we got, I'm not sure how many that was, 8 or something. Took care of them. Aha. Is that it, enemies? Is that all you got? No, you got a bunch more. Okay, cool. All right, this is fun. Okay, so I think that's it for today. Next time, we're going to start adding towers. And every one of these little circles on the castle will be a tower that shoots at enemies when they get close enough. And then we'll also have other slightly larger towers that you can place out on the field, and they will also shoot. And we'll have enemies sometimes target towers rather than the castle. And so there should be a lot of mayhem going on. It's going to be good fun. Should we review what we did today? Yeah, I don't need to clear. Actually, the blue background's kind of nice. Let's take a look. So we did have everything in one main program before. Today we divided it up into several modules. We've got a constants module, which just defines constant colors for now. We have a resources module that wraps up access to the pictures, which are under pics. We did that last time. We moved the player code into player and the enemies code into enemies. So we're starting to get a somewhat larger project, so it's worth organizing. We added functions to detect collisions. And since that's such a generally useful thing, let's take a quick look at that. We'll look at that in the enemies module. Well, first I guess we should look at main, because this is where we added the add bbox function. Adding a bounding box isn't hard, but these 3 lines would have been repeated for each of our different kinds of sprites, so it was nice to just make a general helper function. And then actual collision detection is pretty simple. It's a matter of iterating over all the sprites and checking sprite.overlaps. Overlaps is a built-in method in MiniMicro that uses the bounding boxes to see if the bounding box of one sprite touches the bounding box of another. And then we also used our isFacing method so that you can only damage something if you're facing it. And we added a flash function, which is just cosmetic, pretty simple. And yeah, I think that covers all the highlights for today. Next time we'll add towers, and then pretty soon we're going to have to deal with pathfinding and colliding with the environment. For example, I don't really want the enemies to go through the castle the way they do now. So we'll probably set up a tile display, mark certain tiles as uncrossable, and then we can have our enemies, and maybe the player too, respect those boundaries from the tile display. So tune in next time. Until then, happy coding.